This is Michael Yuan. I want to show you how to use large language model to assist Rust coding in the Zed IDE. Most commercial large language models are not great Rust coding. The reason is that compared with Python or JavaScript, there are too few Rust code examples on the internet. So the large language model has few opportunities to learn. Our approach is different. We use a coding optimized small language model. In this case, we use a 9 billion parameter Q1 coder model. I hosted on my own laptop using Llama Edge and then supplemented with Rust public documentation. It then offers services to the Zed IDE through the Gaia network. My hope is that this self-hosted small language model will return its coding and reasoning capabilities, but be grounded in correct Rust knowledge. Without further ado, let's get started. Our project is a database-driven web application built in Rust. We'll focus on two files. The SQL file contains the database schema. We can see 3 tables, including a messages table. The Rust code file is the web application based on a popular web framework. We use structs to model the database tables in the Rust code. Let's open the AI context. Notice the model we use is our own self-hosted model on Gaia network called Q1 Coder. I'll pull both the SQL file and Rust file into the context. Next, I asked the AI to create a struct for the messages table in the SQL database. But many Rust APIs have structs named message. To avoid conflict, they change the name to logmess. And I do not think I need the database timestamp fields in the Rust application. Now it looks good. We go to the Rust code editor and go to the place we want to insert this struct. The assistant in the editor is aware of the context to the right and inserts the generated code for log message. Cool. This assistant also uses our self-hosted Q1 coder model on the Gaia network. Next, let's open another context to write some code that actually uses this struct. I ask it to write a function to retrieve the database records into a vector of the log message structs. Wow, it wrote not only the SQL connection code, but also in the format of HTTP request handler function required by the web framework we use. I think the reason for that is because we have the whole Rust file in the context, and it saw how other database functions are wrapped in HTTP request handlers. Now I ask the AI to insert the HTTP request handler together with a HTTP router into the Rust source code file. Let's see if we can figure out what is the HTTP router. That's interesting. It did write the router correctly, but not in the right place. That's easy. I'll just move it by hand. It lines up nicely with other routers in the app. That's it. We have now completed a new database-backed API endpoint in our app. Our self-hosted small language model together with its Rust language knowledge base did all the work. Now, you might wonder, what is this application all about? Well, it is a personalized newsletter for Christians. Each subscriber gets a different email every day based on his or her profile and preferences. The messages table stores each email message so that the subscriber can choose to share his or her email on the web. You can try it on pastor-insights.gaianet.ai. What do you all think? Let me know in the comments. See you next time.